Hello everyone, I'm Binja. Welcome back to another video. So as you can see at the bottom right corner, it's Christmas. So Merry Christmas everyone. Although I think this video will be uploaded on New Year's Eve. But anyway, since the recording date is Christmas, so I just want to wish everyone a Merry Christmas. So yeah, and in today's video, we are going into chapter 6 of the IGCSE Math 0580 Extended. So in chapter 6, I think we are gonna have 3 videos. So in this first video, the main agenda will be it will more on trigonometry about chapter 6. So chapter 6 is more about trigonometry, and in this first video it's more on introduction to some according to the syllabus written, the syllabus overview. So number one, I will be talking a little bit about bearings. All right, although it's not like a trigonometry thing, but it's included in chapter 6 as shown in the syllabus content. So I'm going to talk a little bit about bearings. All right, and number two will be I'll be going to introduce to you sine, cosine, and tangent. All right, so tangent, you might heard that last time, but this is a different one. All right, and then the last one for this video will be something called as the wait, why is this so weird? All right, something called as the angle of elevation and depression. Yeah, it's not the depression that you are facing while you're doing maths. Okay, it's the angle of depression that I will introduce to you. What is that later on? All right, so without further ado, let's go into the first agenda for this video, which is about bearings. So bearings, in short terms, it's just all right, it's a very easy one. For bearings, all you need to remember is let's change the color. You're gonna write the angles in 3 significant figures. All right, this is like a layman term for that, although it's not exactly 3 significant figures, but it's because you gotta write in a zero in front, so I better in three figures. All right, so it's like 1 2 3. All right, 0 0 0 degrees. All right, even if it's what, a single digit. Yeah, digit. Okay, so in 3 digits, this is the correct one. All right, so you need to write every single angle in 3 digits. So this is all about bearings, and then it is calculated from the north. All right, so a little guide about if you don't know anything about directions. Okay, so this is the let's use a darker color. So this is the, I need to get a straight line. All right, so this is north. All right, and this is, all right, let's write the whole name, and this is south. All right, and this is east. Okay, I regretted this. I need to write this in the middle so I can include more information about the directions. Okay, so let's draw a straight line here and a straight line like this. Okay, like this. Okay, so at the top part, you have something called the north. All right, so the north is directly above. Okay, and at the bottom part right here, you have something called the south. So the south is the direct opposite of north. All right, and at the right side, you have east. Okay, so this is where the sun rises, and then we have west. All right, it's where the sun what's the called, I don't know, goes down the mountain. All right, whatever. So to determine if you have a compass, all right, then the compass, you need to make sure that the red color, the red side of the compass is pointing north. Then that direction is the north side. All right, so all you need to know is this. All right, and then there are, all of these are 90 degrees. All right, so here is 90 degrees, so north is called 0 degrees. all right, if we in bearings, all right, so north is 0 0 0, all right, and in east, sorry, I'm going to, all right, and in east it's going to be 0 9 0, all right, and then south will be 1 8 0, all right, and west will be 2 7 0. All right, so one thing that I forgot to mention about is this one, uh this thing right here, calculated from north clockwise. All right, so it goes clockwise from north, so it's from 0 0 0, it goes all the way 90 degrees, 180, 270, and back to 360 or 0 0 0. It's equivalent. All right, so next we are gonna have something like this that goes for that cuts 45 degrees. All right, so this thing right here, okay, this thing right here is 45 degrees. All right, and it's the same for everything else. Okay, so the name in between all these will be northeast. All right, it always go the dominant one, so the dominant will be north and south, so you will always write the dominant first, north, followed by the one that is in between them. So this thing right here is in between north and east, so the name here will be northeast. All right, so we write the dominant first, then the next one. All right, and this is going to be 0 4 5, and then this is going to be southeast because the dominant one is south, and then we're going to write the east, so it's between south and east, therefore it's called southeast, and it's 133 degrees. All right, and this is going to be southwest. All right, always write the dominant first, so this is southwest, and it's gonna be 45, so it's 225 degrees. All right, and last but not least, we have this part right here. It's gonna be north and west, so this is north west, which is 315 degrees. All right, so this is all the directions. All right, and then I mean, north sometimes it's not necessary to be 0 degrees, but in this bearing, all right, when you see the question with the word bearing, then north is always 0 0 0, and it follows clockwise. All right, so this is all about bearings, and the concept is actually easy, and I can't stop myself from thinking this calculated, this word looks weird, you know, this looks this weird, but I can't produce any correct one in my mind. So well, if just a disclaimer, if this spelling is wrong, then yeah, just excuse me. Yeah. So this bearing, you will only usually make mistake when you do in the exams, because a lot of people would just write, you know, let's say this one 45, they would just write 45 degrees, then it's wrong, because you must include the 0 in front of the 45, because you must write bearing angles in 3 digits. All right, so this is one thing for you to remember, and these are the directions. Okay, so for more examples about bearings, we're gonna see it more on past year papers. Okay, just a quick one that I have missed about bearings. So I stopped the video, and then only I found out that I forgot to mention about this important example in bearings. Okay, so this is about bearings. So there are some terms of writing in bearings. Let's say, all right, the angle, the bearing of B from A is 260 degrees. All right, so there are two things important one to look for is from. All right, so the thing after from is in the starting point. All right, so this is the starting one, and if you are to sketch according to what they say here, okay, if you are to sketch, then A is pointing upwards north, all right, and this is A, okay, so it will go from north clockwise 260 degrees, all right, and then this will be B, all right, pointing north also, and this is B. All right, so this is the diagram and the information that you can get from the statement given. The bearing of B from A is 260 degrees. All right, so this is how you're going to use the bearing. So from the north clockwise 260 degrees, and you touch this line right here, you will draw all the way until B, and then maybe they will say the distance between A and B is so, then you can calculate. All right, so how do you calculate if you want to calculate the angle right here? So what is theta? All right, so there are a lot of ways that you can look for theta. Okay, so number one, you can cut this, all right, so that this is actually a straight line. So the angle alpha here, alpha will be equals to 260 degrees minus with a straight line 180 degrees. Therefore, this will give 80 degrees, right? So since, all right, from the previous video where we talk about corresponding angles, all right, so this is alpha is equals to 80 degrees and it's equals to theta due to corresponding angle. All right, and you might ask, where did the parallel come from? These two is parallel because they are pointing north. All right, therefore you can use the corresponding angle. All right, if you don't want to use the corresponding angle, you can look for beta right here. This angle right here is beta. Then you know theta plus beta is equals to 180 degrees by the co-interior angle. All right, so you see how all the information that we learned from the previous video kind of works in this video right here. So how do you get beta right here? So 360, okay. So from this, maybe I should use a different color so that you can see by using different methods, you can get the same answer. All right, so I'm gonna use this color right here. So theta plus beta is equals to 180 degrees due to the co-interior angle rule. All right, and we know that beta is equals to 360 degrees minus with 260 degrees. All right, because this is a circle and we minus up everything here, it will left with the beta. Therefore, it will be equals to 100 degrees. And from this information, we can know that theta is equals to 80 degrees and it's the same as the answer that we looked from before. However, this cannot be your final answer because since the question gives you the bearing of B from A is 260 degrees, this is a bearing question. Therefore, you will need to add a 0 in front of any two-digit answers. All right, so it must be 080 degrees. All right, yeah, so this is a little bit thing that I messed up just now, but I will cut it into the video so it starts before the trigonometry. So please do not feel weird if you look at the time, it's different now. All right, thank you. So number 2, the second agenda for today, I'm going to introduce to you sine, cos, and tangent. All right, so this is all about calculator. In this video, we are going to talk about calculator. All right, so from your calculator right here, all right, if you can see, there is a sine, cos, and tangent. All right, so you might want to actually go to your calculator and look at where the sine, cos, and tangent are. Okay, so number one, in your in real terms, it's called the wait, let's write down the trigonometry. Okay, and number one, we have sine. All right, which in your calculator is called sine. All right, so I'm gonna talk about the graph in the next video. So now I'm just gonna introduce to you the terms, all right, the name of these three beginner level trigonometry, all right, or you can just call them basic. Number 2 is cosine, and it's called cos. And number 3, it's tangent. All right, and we will call it tan. All right, so all this you can find it sine, cos, and tangent right here. Okay, so there are some rules that you're gonna remember when you are to calculate when you are to calculate a lot of stuff like from the previous video that I said. So the title right here will be cah soh and toa. All right, so what is cah soh toa, right? You're gonna meet a lot of cah soh toa in your high school maths, all right, no matter it's in maths or ed maths or anything beyond this level, cah soh toa will be your best friend ever. Why? Okay, so the C, all right, I'm gonna describe what is cah soh toa. Okay, number one, the C, S, and T represents cos, sine, and tangent. All right, so the C, S, and T just represents cos, sine, and tangent. Number two, A means adjacent. All right, and H means hypotenuse. All right, if you want to have a guess on what is O, all right, what does O sounds to you? All right, O means opposite. All right, so how this cah soh toa works? Okay, so if you from my previous videos, I said like for example the triangle video when you're gonna look for the area. All right, so how do I get h sine theta and some stuff? So this is where cah soh toa comes in. All right, you wanna memorize it in your own way. It can be so cah toa, to cah soh, or anything. Just make sure that you remember this three phrase. Okay, there's there is actually an explanation for that, but you don't need to know it because I don't know either, and it's not really important. You just need to memorize it. Okay, so for example, I give you a right angle triangle. Oh yeah, this is important. I am very sorry. Cah soh toa can only okay only work in right angle triangle, or anything with right angle. I mean, yeah, technically just right angle triangles. All right, so this is one thing that you need to remember. Yeah, this is actually the most important one, but I forgot to say. Okay, so number one here, we have got, let's say this is 30 degrees. All right, and let's say this is 1, this is 2. All right, so sorry, not this. Okay, let's say this is 1 and this is 30. All right, so from here, if I want to look for x, all right, so x, so cah soh toa right here, the sine, cos, and tangent, all right, in maths, we always work in degrees. Okay, so this works in degrees. Okay, nah, don't need this. Get out of my way. Okay, great. So it always works in degrees. So this is the degree right here. Okay, so you need to see what is the given information and which information you want to look for. For example, right here, if your angle is right here, all right, if your angle is right here, then the longer side is always the hypotenuse. Okay, the one opposite of your angle is always the opposite, and then the last one, the one right beside your angle and it's not the hypotenuse, will be the adjacent. All right, so by looking at this diagram right here, if I'm asking you to look for x, I want to know what is the opposite height. All right, so you have O and you have A. All right, A is given, so you have the angle O and A. So if you're going to refer back to the cah soh toa here, A and H, all right, H is not given and it's not and O is not included. All right, so soh and toa is remaining. Okay, but you need to remember only the adjacent information is given, so you need to use toa. But what does toa means? Okay, so toa is equals to, this means tangent theta is equals to opposite over adjacent. All right, it works the same to all the others. Okay, so let's say cah means cosine theta is equals to adjacent over hypotenuse, and so on. All right, I'm gonna write this in the next page just in case it's not too clear for you. So right here, you're gonna write down tangent 30. All right, it's 30 degrees right here, is equals to, the opposite is x, you want to find, divided by 1. All right, therefore x is equals to tangent 30. All right, and then if you are to press your calculator, all right, so this is the tangent right here. All right, tangent okay, and you can just type 30, all right, and press equals, you will get this 0.5774, all right. Therefore, you know that x is 0.5774 in a right angle triangle. Okay, so this is how you use the cah soh toa, and then for safety purposes, just in case any one of you did not finish watching my video, but just use the cah soh toa in the wrong way, I'm just going to include this in this part right here. Number one, cah represents cosine theta is equals to adjacent over hypotenuse. All right, and then number two, soh is equals to sine theta equals to opposite over hypotenuse. And last but not least, we have toa, where tangent theta is equals to the opposite over adjacent. All right, it's just that easy. Cah soh toa, you just need to remember this, and you are basically 10% done for trigonometry in IGCSE maths. Yeah, so it's just that for this video about trigonometry. All right, and I'm gonna give you another example. All right, so in this example right here, e.g. number 2, okay, I give you a right angle triangle. All right, I want you to find the angle theta, and I give you this 1 and 2. So how do you look for the theta? Okay, first thing you need to analyze what information you are given and what information you want to find. Okay, number one, okay, is the objective will be look for theta. All right, number two, the info given, all right, the info given is opposite of your theta, therefore you have the O. All right, and then it's the hypotenuse, you have the H. So you have O and H. So if you refer back to cah soh toa, which one includes O and H? Yeah, it's the soh. Therefore, you're gonna use the sine. All right. Therefore, you know that this is sine theta is equals to the opposite over hypotenuse, and therefore you know that your theta is 30 degrees. All right, just to double check, sine 0.5, 30 degrees. Okay, so you all you gotta do is just to press your calculator, and you can get the theta. All right, and you might ask, how do I press calculator for this kind of situation? All right, so I'm gonna introduce to you something called the inverse trigo. All right, so let's say number one, sine theta is equals to x. All right, number two, cos theta is equals to x, and number three, tangent theta is equals to x. And they are all equivalent to theta is equals to inverse sine x. All right, so this inverse right here, okay, it's not power -1, and it is not the inverse function that you have. I mean, it is some kind of like an inverse to look for the theta, but it's not the same meaning as the inverse function that you have seen before. Okay, and this will be theta equals to inverse cosine x, and this will be inverse tangent x. All right, so if you in your calculator here, right, at your sine right here, as you can see, there's a little thing on top of the sine, which is the inverse sine. So the left side will be, you press the shift. All right, you can see the same color, so you press the shift. Okay, so you can see a little s right here, then you press the sine button. All right, you press the sine button, then you get the inverse sine in your calculator. And then from the previous example, okay, from the previous example, we are going to look for sine theta equals to half. Therefore, theta is equals to inverse sine 1/2. All right, so you just need to write this inside your type this inside your calculator, press the equals, you will get 30 degrees. Okay, so this is how you work in calculators for this kind of simple trigonometry using cah soh toa in a right angle triangle. All right, so yeah, this is all I can say about cah soh toa about in this video. So now we're going to move on to our last agenda for this video, which is the angle of elevation and depression. So from the start of the video, what is elevation and depression? How many depression can we have? Right, so here, angles of elevation and depression. All right, all you have to do for this, as the name suggests, elevation means you look upwards. All right, and depression, is it double P? No, right? All right, I don't think it's double P. Is from a straight line you look downwards. All right, so what does this mean? It's basically angles of elevation and depression. This is all I can say, right? Elevation is from a straight line you look upwards, and then the angle created will be the angle of elevation. And if you're on top of a mountain, if you look straight and your friend is standing right down there, you look downwards. So from your eye level until your friend, that line, the angle in between will be the angle of depression. All right, so just gonna give you an example. All right, EG1. All right, Ali is 160 cm tall. Okay, the lighthouse is 1 km away. Okay, the lighthouse is 1 km away. 1 km, yeah, okay, 1 km away. Then, there's really not enough space here, isn't it? So I'm gonna transfer everything to the next slide. Okay, just a little while, looking me to erase all this. Okay, so EG number 1, it will be about angle of elevation. Okay, Ali is 160 cm tall. There is a lighthouse in 1 km. Okay, find the angle of elevation that Ali have to raise his head in order to see the top of the how tall is a lighthouse? Let's say to see the top of a say 800 meters lighthouse. Okay, so if you are to draw a simple diagram here to illustrate this, so this is Ali, okay, this dude right here, and he is 160 cm tall. Okay, we're gonna work in terms of meters, so it's gonna be 1.6 meters. All right, and then the lighthouse right here, okay, the lighthouse from the bottom of this land right here is 800 meters. Okay, and this distance right here is 1000 meters. However, there's something you need to remember is this place right here, all right, Ali is 1.6 meters tall. So from eye level, all right, from eye level, he needs to look at the top of the mountain, all right? So this will be the angle of elevation. And if you extend this eye level, it will actually form a right angle triangle. All right, so this is how you can use cah soh toa in solving angle of elevation. So how do we solve this? So first thing first, you need to minus out. All right, you need to minus out the distance here because we are using eye level and we are not using the from the bottom, right? Therefore, 1.800 meters. If we transfer the triangle out here, this is going to be 1000. This is the theta we want to look for. And this place right here will be 800 because the total height is 800 minus with 1.6. All right, 1.6 meters. So this is going to be 798.4 meters. All right, so this is very important because usually in exams they like to ask this kind of question, and a lot of people will miss out the height of the viewer. All right, and this is very important to minus out from the total height with the height of the viewer. All right, so from this we have theta, and then we have the opposite value, and then this is not the hypotenuse. Hypotenuse is the longest of the triangle. Okay, therefore this is adjacent. All right, and if we are to refer back to cah soh toa, all right, and there's only one thing right here which doesn't need the hypotenuse, which is tangent. All right, therefore in this calculation right here, we are going to use tangent. Let's change color. Let's use this color. Tangent theta is equals to opposite over hypotenuse. All right, and then if you press your calculator using the shift, all right, and the tangent, okay, and you include and you type 798.4 divided by 1000, you will get the angle is 38.6 degrees. All right, and if the question asks you to write in terms of bearing, and then it's going to be 039 degrees. All right, so it really depends whether the question want you to write in bearings or whatnot, considering it's the north or anything. So you're just gonna write that, and yeah. So this is how you use the tangent, the cah soh toa and stuff. All right. So for angle of depression, right here, okay, angle of depression. It's pretty much the same concept. All right. So you need to imagine you are on top of a mountain. All right, and you are standing right here. Yeah, you're standing right here, and then there's an object A right here. So the angle from your eye level to object A, this angle right here is the angle of depression. All right, so it's not about sat, but it's about the angle where you look down from your eye level. All right, and this forms a right angle triangle. Same thing, use the cah soh toa to solve. Usually in this kind of situation, the length here is given, and the height of the cliff and the viewer is given. So you need to add the height of the viewer and the cliff, and then this one will be the horizontal distance from the viewer to the object. All right, so in usually this angle of elevation and depression, we usually use tangent because no one is going to give you the hypotenuse where you're just going to look down or anything. It's rare, but it's possible, but it's rare. Okay, so yeah, I'm not going to give an example because I can't think of any. I mean, it would just probably be the same, saying that this is Ali, this is 1.6 meters, and this cliff up here is 800 meters, and the horizontal distance is 1 km, and the angle of depression will be the same thing, which is wait, actually it's not. All right, so let's write down this. Oh, okay, let's write down this thing right here. Ali is 1.6 meters. The cliff is 800 meters. All right, horizontal distance is 1 km. Look for the angle of depression. So now if we are to transfer this triangle right here, the theta is right here, this is 1000, and this thing right here is 800 plus 1.6. All right, from the previous example, we need to minus it out because it's from our eye level to the top. All right, so everything bottom doesn't matter. However, now we are going to minus out, all right? So from the eye level, look to the bottom. So we need to include the height of the viewer and the cliff, all right? So tangent theta is equals to opposite over the hypotenuse. Therefore, if you press your calculator, all right, 0.6 divided by 1000, make sure that you get something like 38.7 degrees. All right, so this is supposed to be the answer that you get. Okay, 38.7, and then as you can see, it's very close to the previous one because a little bit of decimal places right here is gonna make a very slight difference. All right, and just a disclaimer right here. All right, I just thought of it when I'm talking about it just now. Disclaimer: height of Ali is assumed to be eye level. All right, so if I'm saying Ali is 160 cm, then it means from his toe up to his eye level. All right, so yeah, this is something that you might see. It's assumed to be usually on eye level, so you need to add in or you need to minus it depending on the situation. All right, so yeah, this marks the end of the video, where it's actually a more diverse one. It's not something like a focus because we talk about bearings, where you need to write angles in three digits. Okay, and number two, I introduced to you something called sine, cosine, and tangent, which are the three most basic trigonometry in trigonometry. And I introduced to you cah soh toa, these three terms for you to solve a right angle triangle problem. And last but not least, I had introduced to you angle of elevation and depression and two little examples on how this can be tested in exam. So yeah, I hope you guys understand this video. In the next video, we are going to be learning about graphs and a lot more about sine, cos, and tangent. So I hope you guys are looking forward to it. I'll see you guys next time.